Hey Taylor, so let's just do a quick run through the problem real fast. Let me see if we can look at this problem for the application when it comes to the price supply equation and the price demands equation. So two things we want to kind of emphasize here. They say that price $2.23, so 23 per bushel. We're supply certain grain for 74 million right there. That's 74 million, and the demand is 77 million. At $2.32, the supply is 7,800 million, and the demand is 7,600 million. All right, so just be clear. So 7,400 million for my supply, and 7,700 for my demand. And at $2.32, it's 7,800 million. For my supply and 7,600 for my demand. So I just need a coordinate pair. So all I need right here is going to be my supply. And for the supply, I'm going to have 7400, and the coordinate pair matching that is supposed to be 2.23. Also, I'm going to have 7,800, good, which is matching if I $2.32. All right, so that is my situation there for my coordinate pair for the supply. For the demand, on the other hand, I recognize real quick, I'm going to have 7,700, right, for $2.23, and 7,600 for $2.32. So that's going to be the coordinate pair for my demand and supply. So let's run through this real quick and see if we can get these values real fast. So to do that, I kind of make life a little bit easy. I went ahead and did the calculation in advance to make the process a little bit quicker. So what we're going to do is, if I go back to my email right here, I want you to see this clearly. So real fast, let me just pull that up. We got the coordinate pair. So that's the coordinate pair for my demand and supply, if you can see that pretty clearly. Once I do that, I'm going to get my slope. So to get my slope, I use a slope formula, y2 minus y1 over x2 minus x1. Now once I do that, I plug the values in for y2, y1. I get my slope of 0.00225. For the demand, I do the same thing. I do my y2 minus y1, and I get my slope as follows. Pretty straightforward once you remember this formula. So once you have that now, we're going to use a slope-intercept form, or point slope form that is my y minus y1 equal to m x minus x1. Now with that being the situation, all I need to do is just pick one of the points. In this case, I pick 2.32, and I pick 2.32 and 7,800. So that's giving me my equation in this line. So after I give my equation this line, I simply just expand, simplify, bring everything to one side, and I got the equation as follows. That's my equation. Same story right here. I select the point 7600 and 2.32. Once I use that point, I just plug them in, work it out, and I get this as my equation. Once I get both equations, life becomes super easy now. All I simply need to do, just write this in terms of P, because this is my supply equation, and this is my demand equation. So my solution point for both of these equations, when I find the solution, going to be this. So what I did is just put these into Desmos, if you can use Desmos or the TI-84 calculator, and my result was as follows. Just that's my equation, and I can read off the intersecting points, and that would complete this presentation. Pretty quick, pretty sniffy, not a lot for calculation here, and that completes this problem.